Okay, and today we'll discuss one of the dynamic routing protocol that is a EIGRP. EIGRP stands for Enhanced Interior Gateway Routing Protocol. So basically, we discussed yesterday we have two types of protocols. One is internal and one is for external. Internal, it means IGP protocols, IGP protocol, and apart from that, we have a EGP protocol. AGP protocol, that is, it will be work between AS, it will work between AS number, autonomous system number, and it will work within AS, within a AS, within AS number. It will work within AS number. So one of the protocol we have IGP protocol, that is EIGRP. So basically, as we discussed yesterday, EIGRP is a earlier it was a Cisco proprietary protocol. Now it is a open standard protocol. It means earlier we are using the Cisco devices. That Cisco devices only the protocol was working. Now it's open standard. Even though if you are configuring here we have a this is a Cisco device and this one is a HP device or Palo Alto, any other vendor. So definitely it will be work. If you are using a different devices also, it will be work in a between neighbors field form. That is what Cisco proprietary and non-Cisco devices. So earlier it was a Cisco proprietary and now it's a open standard and it is a IGP protocol and it will be work within AS means internally will use. Internal means now coming to the internal means I'll give the overview. It's our LAN network, how they are connected. So here we have a switch and switch is connected multiple access switches and access switches. These all are the access switches and access switches are connected to users or access points, something. So same likewise, these all are the our internal network and this one is the our edge router, customer edge router, customer edge router. This one is edge router. So C we call it and it's connected to WAN and WAN is connected to some internet, something internet or if you are using the different branch at different location, yes, definitely. So likewise, but EIGRP, where we will use internal means our LAN network and our LAN network will use. So this is what IGP protocol and it will be work within AIS. Okay, this is the brief introduction of EIGRP protocol and we'll discuss something else to documentation. So EIGRP stands for Enhanced Interior Gateway Protocol and it is an open standard routing protocol. Earlier, it was Cisco proprietary, but after time gap 2013, Cisco declared it is an open standard protocol. After 2013, Cisco declared, and it is a layer 3 protocol. Basically, yesterday what we discussed with protocol, RIP protocol is a layer 7 protocol and it has uses for UDP port number 520. Like same here, it will be used. It's because it's a layer 3 protocol. That is number. That is the reason it has a protocol number that is 88. And through protocol number, again, we will identify the service. We will identify the service. So it has a hybrid routing protocol because it has feature of both distance vector as well as link state routing protocol. As I told yesterday, it's EIGRP only the protocol we have. That is a hybrid protocol. So it has a two features like distance vector features also. And link state routing protocol means whichever the OSPF, OSPF and plus RIP protocol, both is equals to EIGRP. It means it's a link state, and it is a high distance vector. So likewise, we'll get. So we'll discuss why it is we call it as a hybrid mode, hybrid protocol. We'll discuss later on, but it is a hybrid protocol. So it is also known as advanced distance vector routing protocol because so it has a two features. That is the reason it is advanced distance vector routing protocol. We call it as, and it is an interior gateway protocol, IGP protocol, as we discussed, and it is a classless routing protocol. What does that mean? Classless, and RIP was a classless or classful. RIP has two versions: class full for the version one and classless for the version two. And class full will not carry the subnet mask information. Subnet mask means if we have a full subnet slash 24 slash 16 slash 8, these all are the class values. It's a full fixed length subnet mask FLSM. And we have another variable length subnet mask. So what does it mean? If you got a one subnet mask, that is 192.168.10.0. You got a, this is the subnet mask. In that subnet, you got it's a class TIP address. So 255.255.255.0. It's a 255.255.0. So your requirement is each department, we have a four departments here. We need again four VLANs, VLAN 10, 20, 30, 40, you can assume. We have a four departments, different departments. Each department, we have a users, 50 users. So 50 users. That time, we can assume. So we'll use fixed length subnet mask. That time, here you will say 50 users, and here 50 users, and here 50 users, and here 50 users. This is a fixed length. Now coming to again same scenario, but now we have a at VLAN 10, 20 users we required, and VLAN 20, we need a 30 users, and VLAN 40, we need a some 40 users required, and VLAN 50, we have some VLAN 50, we need a 50 users. It means 30, here we have a 30 means some 35 users required. So likewise, it's a variable length subnet mask. Definitely. So this is a box we have again. So here we need 20 users, and we have a 30 users here, and here we need a 40 users. So again here we have a 50 users something, and here we have a 35 users. So we'll segregate, like we have a slash 25 slash 26 slash 27. So this is the subnetting concept. Just I'm giving the overview. So slash 29. Based on the slash values, we can segregate. So EIGRP will support this concept. This is the concept of VLSM, variable length subnet mask. So only the RIP protocol is a class, that also version one only. RIP version one only, class full protocol. Class full protocol. That is the reason it will be support only fixed length. But EIGRP and OSPF and BGP, these are the protocols we have. It will be support FLSM as well as VLSM. Fixed length subnet mask. This is a fixed length subnet mask, and this is a variable length subnet. So I believe everyone got what is a classless, classful, and classless means it will be carrying. This is the subnet mask. It will be carrying this all the subnet mask. Classless means it will be carrying the with subnet mask, and class full means it will be not carry this subnet mask. It will be not carry. Class full means it will be not carry this subnet mask. Class full. It will be carry only the whichever the full subnet mask, class full subnet mask only it will be carry. So that is what. And EIGRP is a classless routing. Yes. And it send triggered updates. So here we have a timer 5 seconds and hello timer and 15 seconds. It is a dead timer. I'll explain this triggered update. It will be send triggered update, and it means AHRP router does not send periodic update. It will be sent full routing table information. Whenever any issues happen, that time it will be sent again full routing table. So EIGRP will send. So sorry, uh, RIP protocol will send the full routing information. EIGRP it will not send the full information. I'll discuss why it is. So EIGRP will send update only when changes occur in topology. So here you can check whenever the changes occur, whenever any port is down. So I'll we'll discuss. So this one we have a one router, and here we have another router. In between we configured EIGRP through route router EIGRP, and we'll give you some AS number, and we have some LAN prefix here. We have we can assume one LAN prefix here, and we have another LAN prefix. So we have like here LAN prefixes 192.168.10.0 slash 24. Here we have some other LAN prefix. One is that is 172.16.10.0 slash 16. The value is there, and it's a class B and class C. And so by default, once we configure EIGRP, they will send hello messages together, and that is, and after then, if any we configure value, any new value means no prefix came. So that time it will be sent only this prefix 192.168.20.0 slash 24. After while scalable network, because of it's a scalable, so new prefix came, we advertise it through network command. That time it will be not sent because this route already have this router. This router to have already this path. Again, whenever the new prefix joined our network in topology, that prefix only it will be sent. If one more thing again, whenever the changes occur, that time only it will be sent. It means if it is new came, then it will be sent. Again, some reason, again we got one more prefix that will be sent. And somehow the prefix, this VLAN is goes down. So this goes down, whichever the prefix goes down, that only it will be sent. So that is what. Again, one more thing, they will maintain a neighborship that is every 5 seconds. They will send a message, hey neighbor, you are alive or not? Hey my neighbor, are to you are alive or not? He is sending one message. Again, he is giving the reply. If he is not giving the reply till 15 seconds, that is dead timer actually. Hello timer is 5 seconds, and dead timer is 15 seconds. If he is not giving till 15 seconds, then this router will assume like my neighbor is gone. My neighbor is gone. No neighbor, no. So same like as if we have a multiple routers, multiple connectivities, he will send every 5 seconds to neighbor, you are alive or not. That is what hello timer and dead timer. So for that, it will be used one algorithm, that is dual algorithm. It will be with the help of diffusing update algorithm. They will send periodic update. Any changes occur, any topology changes occur, any entire thing will change. So updates will be based on the dual algorithm. They will use the diffusing algorithm, diffusing update algorithm. And in EIGRP, if two routers are configured with same AS, so here we have a AS number, autonomous system number 100, and here autonomous system as a 100. Yes, then neighborship will be formed in between. Neighborship will be successfully formed. Otherwise, if you configure, try to configure in between, in this router, you configure as the AS number 100. Here you are configured AS number 200. Then AS number is mismatched here. So AS number mismatch means no neighborship. So AS number is mismatching means no neighborship they form. If AS number match, then only they form the neighborship. So that is what in EIGRP, if two routers are configured with the same AS number, then neighborship will be formed and between them. So if different AS means no neighborship. And EIGRP traffic will either send as unicast, either it will be sent use multicast IP address, that is 224.0.0.10. So yesterday we discussed what is multicast. It will be sent one to group messages. So RIP version 2, we have a one multicast IP address, that is 224.0.0.9. So here we have a EIGRP uses multicast as well as unicast. When multicast, when unicast. So here we have some message types. So we'll discuss this point. We'll discuss. Okay. It is reliable protocol because it provides the acknowledgement of the update. Yes, it is a reliable protocol. Why it is reliable? Yes, we'll discuss together. We'll discuss together why it is reliable. It uses the just it is set TCP protocol. We'll discuss these things also. How it will be reliable, and it uses RTP, Reliable Transport Protocol, to ensure the delivery and acknowledge. This protocol will use one method, that is RTP. This is the protocol we will use for reliability purpose. And maximum hope count is 255. And by default, hope count is 100. So EIGRP having hope count 1, 2, 3, 4, 5 up to 100 by default hope count, it will be send the packet. If you can maximum, if you want to send the packet, yes, after 100 also you can send. And with having maximum hope count is maximum hope count how much? Maximum hope count is RIP 15. Now, coming to EIGRP having maximum hope count is 255. Hope count is maximum is 255. So it uses RTP. So same thing, and get the reliable update in EIGRP protocol. But hello message will not reliable through RTP. So why it is not a hello message? I'll discuss once we'll discuss the message type. So it uses some timers. So that is what hello timer, and hold down timer is 15 seconds. If you want to change, yes, you can change it. If this command, through this command, we can change the hello timer and date timer. So, and it has a AD value 90 and 170. 90 is the internal routes, and external, whichever the redistributed routes. So those route will get 170 AD value. So based on the AD value, it will be select the best path. So how routers will select the best path? Yesterday we discussed. So first it will be check highest prefix. If highest prefix is type, then it will be moved to the AD value. AD value, and AD value also match. Here 90, and here also we are using 90. So we have a two path for this route. It's the destination we have. So 90 90. Then a tie here, AD value also tie. Then it will be moved to the metric. Metric. So RIP having the metric is hope count. So here we have a formula I'll discuss. Here in EIGRP for metric part, we have a formula. We'll discuss K value. It supports both equal cost and unequal cost. So EIGRP having only the unique uh, feature, that is a here it will be support equal cost load balancing as well as unequal cost load balancing. First of all, what is load balance? First of all, what is load balance? So here I have some router. This is my source and destination. This one is my source and this one is my destination. In between, we have some routers. One, two, three, four. So this is a path. It will be select. How it will be select the load balancing? What is load balancing first of all? So these are my paths. So here the connectivity is 100 Mbps link, 100 Mbps link, and same this one also 100 Mbps, 100 MB link, and same here also this link also 100 MB, and this one also 100 MB. It means it's a fast Ethernet link, FA link, fast Ethernet link. That is the reason all of the FA links, fast Ethernet links, FE, fast Ethernet links. So all having the 100 Mbps link. So the speed is same. So the route one user is there and we have another user and four users you can assume four users we have through this LAN network. So that time he wants to talk, some server is there. In this server, some abc.com site is there. So this user wants to try to communicate this website abc.com. So he originated traffic towards this path, and this path is now communicating to is busy with this path. So this is path this user is using. This path is this one is user is using. This path is this user is using. So this is what EIGRP will support up to four paths. Four paths we can use load balancing. If you want to, yes, we can use. And here we are using 1 gig link. So now the this link is gone. So we are using 1 gig link. 1 gig link. Here we are using 10 Mbps link, 10 MB link. Here we are using 100 MB, some kbps serial link. 152 something. We are using kbps. So if you want to send a traffic, yes, this is what unequal load balancing, unequal cost load balancing. So it will be support both equal cost and unequal cost load balance. Yes, it support equal cost and unequal cost load balance. So this is the basic introduction of EIGRP entire thing, and it has some routing tables and topology table and neighbor table. We'll discuss now routing table as we discussed yesterday. First, we'll discuss neighbor table. What is neighbor table? This is one router and this is another router. We configured EAGRP in between like router, router EIGRP. Then I'll use here 100 is a case number and through network command I'll advertise. Here we are using 11.1.1.1 the prefix 11.1.1.1 for 0. We have to advertise entire network. So through network, we advertise this prefix, and if you can hit enter, it will be work. Otherwise, you have to use wildcard mask. Wildcard mask is nothing but opposite to subnet. So wildcard mask means subnet mask means 255, 255, 255.0. So opposite means we have to use like so what is wildcard mask? I'll show you something here. 255.255.255.0. This is the actual subnet mask. Now, here again, how you will get the wildcard mask means 255 again, subscribe it, minus it, the value will be here. So, opposite to subnet minus. So, 0, 0, and this one is 0. And here we get 255. That is what. This is a wildcard mask actually. We have to use in RIP as not in RIP. In EIGRP as well as we use this concept at OSPF also, in ACLs also, everywhere will use this is the. Likewise, we have to advertise the prefix. This is what wildcard mask. So we advertise it successfully. Then this R1 and R2. Now what happened? So this router we have configured EIGRP through multicast IP address. It will be send a message through which interface? This interface. Because here we are using the IP address is 11.1.1.1/24 slash 24. And same thing, same subnet we are using 11.1.1.2/24. We are using this subnet. So, so directly connected some fast Ethernet FA 0 by 0 something, and here also FA 0 by 0 something like 0 by 0. So this router now start to send EIGRP messages through multicast IP address. So that is what hello message. This is the hello message. And if we configure here EIGRP same through same likewise, same subnet mask, authentication is entire thing is there for neighborship parameters are there. What are those neighborship parameters means AS number is must match and subnet whichever the subnets we are using, this is a subnet that should be matched. And if you are configuring any authentication password, so if you are using password is ABC in this router and ABC on this router, so MD5 and plain text this also support. So same password should match. So these are the neighborship parameters. Then only it will be found the neighborship. So we configure entire thing, same thing. This is what we configure here also. And router EIGRP 100 and network 11.1.1.1. If we configure, then he will give the unicast reply. Unicast reply. Hey, yes, I am the neighbor. If you want to check, so here I'll show you something in this diagram. You can verify this. So initial route discovery, neighborhood discovery, how it will be established. Yes, my screen is available. Will it be visible? Can anyone confirm me?
Yes, sir.
Fine.
Yes,
Router A and
Teju.
router B. So I am router A who is on the line. He is sending one message. This router is sending one message. Like I am the router A who is on the line. So if we configure entire thing what we discuss here, then he will give the reply. That is unicast reply. So if we not configured something mismatching is there, mismatching of like subnet mask or AS number or authentication, anything is mismatched, then he will not give the reply. If entire thing is proper, then he will give the reply. This router we will give the reply. Yes, I am router B. So they successfully establish a neighbor. This is what router neighbor table. So how will verify the neighbor table? So here we can check. So for neighbor table, we can verify show IP neighbor command. Show IP EIGRP instead of this topology, we'll use neighbor table, neighbor command. So here you can no. So IP EIGRP neighbor through neighbor command we can verify it neighbor. I'll show you in lab. So, and once the neighborship is formed, then this router giving one update message. Here is my complete routing information. So, apart from that, he is giving entire routing table. So he is giving the acknowledgement message. That is the three-way handshake. Likewise, here it is giving the acknowledgement message. Thanks for the information. Whichever you have given your updates in complete routing table. Yeah, thank you for you whichever you are giving the information. He is giving the acknowledgement. So again, the router A also. Here is my complete routing information. This router also giving entire routing information. Yes, I do have LAN, VLAN 1, VLAN 10, VLAN 20. These are the prefixes I do have. These are the my VLAN prefixes. I do have. Yes, take these prefixes. This router also giving the unicast prefix. So both once they will exchange, that is the global routing table. So here we have neighbor table, topology table, routing table. So EIGRP will maintain three tables. One is neighbor table, one is topology table, another one is routing table. So this is what? This is a routing table, and this one is the topology table, and this one is the sorry, this is a routing table, and this one is the topology table, and this one is the neighbor table. I'll show you how we'll verify the show IP route command and how we'll verify the topology table entire. So the neighbor and topology table information will be maintained by the hello and update packets, and routing table will be maintained on the behalf of the topology table. I will discuss entire thing once we'll start the practical lab. So EIGRP, how they will calculate the metric value. So based on the K values, here we have K1, K2, K3, K4, K5. These are the K values. K1 is nothing but bandwidth, K2 is nothing but a load, K3 is nothing but delay, and K4 is nothing but reliability and MTU, maximum transmission unit. So by default, MTU size is 1500. Those I will show you in lab. So if you want to check this, so this is what yesterday lab. What is bandwidth? I'll show you some interface. So show interface fast Ethernet 0 by 0. This is the interface. So here you can see this is a bandwidth. It's in kbps actually. This value is kbps and this is MTU size, maximum transmission unit size, and this is the delay 100. So it will be vary based on the interface which we are using. If we are using fast Ethernet, yes, that is 100 Mbps link. This is the in kbps it is showing here. So if you want to check, see here the 100 Mbps. The link is 100 Mbps. If you want to check in bandwidth, that is available in kbps. So this is what, and delay, how much delay it will be showing. It is millisecond. It will be showing here. So this is what, if you want to change, yes, we can change it. If you want to change delay and bandwidth something, yes. How will change? Just move to interface fast Ethernet 0 by 0 and just give the delay, and in this value how much you can change it. So the by default value is 100 here it's showing. Instead of 100 I use 1. It will be value is like into 10. So whichever you are giving here, the value it will be show into 10. If you are configuring 1 means the delay will be final result will be 100, sorry 10. So if you are giving 10 here, the final result will be 100. If you are giving 100 means the value into 10,000 like will get into 10. So whichever you are configuring, it will be into the value will be count. So I'm giving the only one. So do show interface FA 0 by 0. So you can verify. Yes, if you want to change delay, is we can change the delay once you move to interface level. So if you want to change the bandwidth, is we can change the bandwidth also. So it will be applied on only for the EIGRP. So whichever the you are changing the value, it will be if you want to change the path manipulation, that time will use. So because here we have a two paths, one and two. If you want to send a packet instead of this path route, you can send to changing the delay something, delay or bandwidth. Yes, you can change the path manipulation through this thing. So based on that, so it uses some formula as I told. So by default, values are here. So by default, serial interface, it uses kbps value and Ethernet having 10 Mbps into 1000 means you will get the value in kbps. Whichever the result you will get, that is in kbps into 100. So fast Ethernet having 100 Mbps and this gigabit having 1 gig means 1000 Mbps and 10 gig having 10,000 Mbps. If you are into the value, you will get the kbps in value. So by default, we'll get like so in kbps and interface. So this is the formula. So we can calculate it. So 10 to the power of 7 divided by least bandwidth. So least bandwidth means K1. Here the value is K1, least K1 value plus total delay. Delay means here K3. So mostly we'll use on. This is the value we'll use. Apart from that load, reliability, MTU. If you want to change, yes, you can change the value. But sometimes not required also load how much load if you are changing. So if you are sending some packets from source to destination, so if you are sending the traffic is y, the load is different. If you are sending the mail text traffic, that is the traffic is different. If you are sending the music traffic is different. So video call, that is the different of traffic. Based on that, it will be. So if you are changing the value means it will again and again the path will be changes. So it will be used as a different path means if you are changing the value means load and reliability, MTU sizes. So so always sometime it will be used this path and sometime it will be used this path. So CPU utilization is more. So that time will not use. So that by default the bits are off. You can check here. Mostly will use bandwidth and delay. These values will use. These values will not use in real time. So likewise we can verify it and this is the delay values and 20,000 for serial interface and here 10 1,000 is for some printing mistake. So so 1,000 for Ethernet and here 100 for Ethernet and 10 for gig thing and 1 for 10 gig. So this is what. And if you have any queries, ask me. Otherwise, we'll move to the lab. And we have a here message types. So here we have a hello message, and here we have a update message and query message and reply message and acknowledgement message. That is what we discussed here. First, this router sending the hello message. This router is giving the reply and how many updates this router having means routing update. It will be give the update message and this router will be give the acknowledgement message. These are the message types we have in EIGRP. Five types of messages we have and you can go through the document. Same thing you will get. So that is what these all are the advanced level. Fine. If you have any queries, ask me. Otherwise, we'll start the lab.